Channelized bandwidths for logical connections is a feature that's been introduced for telecom network inventory in the Washington, D.C. release. Channelized bandwidths are used in a couple different scenarios. The primary scenario would be for a broadband fiber provider to model logical connections for their DWDM network. So you have network connections that have multiple wavelengths of fiber optic signals going over one circuit. And logical connection channelization is used to allow each of those wavelengths its own logical connection as part of that parent logical connection. So you could have one fiber circuit that has 8 different wavelengths going over it, and that's done through logical connection channelization. Let's see how we do that. So if we go into our logical connection models, we're going to create two different logical connection models. The first we're going to call this optical multiplexer section. So this is a logical connection model that's going to be used to represent the circuit that will carry the channelized bandwidths. So you can see my model category is set to logical connection. If I scroll down, I can see that there is a behavior field here that is set to connection. If I look at that, you'll see that there's two choices. The first is connection, the second is channel. We're going to use the channel connection, the channel behavior to define our channelized logical connections in just a second. And then we also need a reference to our logical interface model, and that's been done here. That's our optical channel interface. We'll take a look at that in a second. So here's our optical channel model. This is the model that's going to be used to represent the channelized individual wavelengths on that logical connection circuit. So again, our model category is logical connection. And if we scroll down, we can see that this time the behavior is set to channel. And the logical interface model referenced here is our optical channel interface. And so let's go up and take a look at our optical channel interface. So this is a network interface model, different from the logical connection models. So this is going to be a model for our ports associated, well, actually not the ports because these are virtual interfaces. So it would be a virtual network interface. And when we're setting this, this optical channel interface, anytime you're setting the channelization on the model, you need to, or on the interface model, you need to set this flag to virtual. And then you can say the port bandwidth for this particular one is going to be 1 lambda. And so we've got the three models that are used to create these logical connection channelized circuits. The one thing that we're going to do to tie them together is we're going to create these network model relationships. So you can see that on my logical connection model for my circuit, I've got two different relationships. I've got one relationship that was created that's going to assign 48 child lambdas to the circuit. And then I've got another relationship that was created for this circuit that's only going to create 8 lambdas, or 8 channels, each for a lambda or a wavelength. So if we drill into the 8 lambda relationship here, you can see that my parent bandwidth is going to be 8 lambdas, my child bandwidth is 1 lambda. And it's referencing my optical multiplexer section model, and it's also referencing my child product model, my channelized logical connection for my optical channels. So if we go back and take a look at some of the circuits that were created using these models, they were done using this template. So I went and I created a 8 lambda OMS template. This is a template that's going to be used when we create a logical connection that has 8 lambdas, 8 child channels, 1 for each lambda. And I can see that the related templates associated with this are 8, it goes from 0 to 7, and each of these represents a channel on this circuit. So let's take a look at one of these logical connections that were created using these models and template. So I can see I've got my logical connection, and more importantly, I can see that if I look at my infrastructure relationships here, I've got 1, 2, 3, 4, 5, 6, 7, 8 child channels. And each of these channels is associated with a wavelength. Now, the naming conventions for logical connection channels is pretty standard. It's out of the box, but you can implement logic for your naming so that your channels have some indication as to the particular wavelength associated with that channel, like we've done here. So that's a quick review of logical connection channelization, a new feature from TNI in the Washington, D.C. release. Thank you.